Hello, everyone. Thank you for joining us today. I'm Luka Berkic from the Business Department of PAL Robotics, and today I am accompanied by our senior scientists for AI and social robotics, Raquel Ros and Séverin Lemaignan. Prior to joining PAL, both of them have worked as associate professors in universities, so they're quite knowledgeable on topics of HRI and also how to use ARI for teaching. During today's webinar, we're going to tell you a bit more about our social robotic platform. So we're going to tell you more about hardware, a bit more about the software updates that we've been working on. And lastly, we're going to speak about why ARI is the ideal platform to use for teaching. Of course, during the presentations, please feel free to ask and vote for questions in the chat. After the presentations are done, we're going to dedicate the last 10 minutes to address some of the questions live. Yeah, so starting with the hardware overview of ARI. So as you can see me standing next to the robot, you can see that our height is quite similar. So ARI is 165 centimeters tall. Going from the head of the robot, at the forehead, we encounter the first sensor. So what we have here is an RGB camera. Of course, it is also possible to get an upgrade and get an RGBD configuration or a combination with a thermal camera. Going below, on the face of the robot, we can find the expressive eyes, which are LCD screens that support custom animations. A bit more about the topic of expressiveness, you're going to hear during the presentation of Séverin. Looking at the sides of the robot, we find the ears, which are LED rings, which are, of course, also customizable. Moving forward, here we find the arms. So each arm has 4 degrees of freedom. So starting from the shoulder, you have 2 degrees. Going to the elbow, you have an additional degree. And lastly, the forearm has 1 degree of freedom. On the torso, we find the touchscreen. And it's important to note that this is not an Android tablet. This is basically a screen which is directly connected to the onboard PC of ARI. So what this means is that it's extremely easy to display any kind of custom content that you would wish to show. An additional thing that is quite interesting about the screen, as it's mounted outside the torso, it is possible to add additional sensors in case you're required to do so. So basically on the sides and on the top of the screen, it is possible to add an RGB, RGBD, or a thermal camera. When it comes to the onboard computer of ARI, so ARI can be purchased with really powerful specs. So we offer ARI with an Intel i9, 32 gigs of RAM, and a terabyte SSD. Additionally, recently, we started offering powerful GPUs from NVIDIA. So now in our offer, we offer the NVIDIA Orin and also the NVIDIA Xavier. Moving forward with the sensors. So below the screen, we find an additional camera. So what we have here is an RGBD, which is used for detection of nearby obstacles. Below the torso, we find an array of 4 microphones. And below, we have stereo speakers. So now to show you the back, I'm going to ask Raquel if she could teleoperate and turn ARI around for me.
Just a sec. I want to make sure. Yeah, I'm going to move her now.
Brilliant.
Turn a little bit now. Maybe let's just do it manually.
Yeah, let's do it manually at the moment. All right. Yeah. Brilliant. Thank you, Raquel. Okay, so here we can see the backside of the robot. So at the top, of course, the emergency button. So basically the button, when pressed, takes away the power from all the motors in case this is necessary. Underneath, we have an additional sensor. So right here, we have a fisheye, which is used for detection of the docking station. Below, we find the buttons used for powering ARI. And then lastly, here we have the expansion panel. And also, it is interesting to mention that recently we started offering a LiDAR possibility for ARI, which gets installed at the back of the robot. And with the LiDAR, basically ARI gets very powerful navigational possibilities. So this was just like a very quick overview about the hardware. So now we're going to speak a bit more about software, and I'm going to hand over the presentation to my colleague, Séverin.
Thank you, Luca. Yes, over the last couple of months, enabled by all the new hardware capabilities that we've added to the robot, we've been able to add quite a few new software capabilities to the robot. So if you get an ARI today, it comes out of the box with quite a few features to make it possible to do more advanced behavior. So I think we are going to cover, I'm going to try to show you quite a few of those. Maybe we can have a quick overview. So I will briefly show you how we can do like social perception with the robot. A few examples of speech processing, dialogue management. Luca already mentioned expressiveness. I will show you, for instance, how we can change the eyes. Navigation is an important thing that we can do quite well with ARI when it's equipped with a LiDAR indeed. I'm quite excited about the new reasoning capabilities that we've included in the robot. And very briefly show you a couple of motions. Raquel, a little bit later, will actually show you how to build the motions. So to get started, what you can see hopefully on your screen now at the bottom is a live stream of what is on ARI's screen. If I click on it, it should update, and this menu, this first set of buttons, is what you would get if you turn on for the first time ARI. You have this kind of little demo that showcase what the robot can do really. So I'm going to click on check what I can do, and we have those 6 categories that correspond more or less to what I was telling you about. Face recognition, speech processing, expressiveness, navigation, reasoning, motions. So maybe, I mean, let's get started. Let's try. Can we maybe try again to move the robot maybe a little bit towards me so that I can play a little bit with face recognition?
Let's see how much it was to help today. So it is, we start moving, and yeah, the thing is that as you will mention later on, navigation is a bit stretchy here, so it's kind of not fully working, and then for
it's stuck because of too many obstacles.
Yeah, exactly. So it doesn't want to really move.
There's a bit of a demo effect here. I fear it was working this morning, but anyway, I'm going to turn off the motors again as we did a minute ago, pressing the red button, and just turn the robot a little bit towards me. There we go. Up, unlocking the motors. All right, if I press on face recognition now, what you see on the screen is the live face detection capabilities of the robot. Actually, if I invite Luca to join me, we should be able to see both of our faces.
Hello, Ari.
You can see right now that the light conditions are not ideal. We have a very strong backlight, so that doesn't help with the facial detection, but still it seems to work. You can also see on the screen the little IDs next to our faces. So the robot will associate a unique ID to each of the faces. And once it knows us, it will be able to reuse the same ID, enabling facial recognition. This is one very simple example. Face detection is not something really new. What is important to mention here is that first, we have integrated all that with Ros, and I will say a few more words about that in a moment. But also that, I'm going to turn it back to you, that it's not just face recognition. What comes now by default with the robot is, for instance, skeleton tracking, 2D, 3D, real-time skeleton tracking. We have also things like automatic engagement detection. We can extract facial features. So all that is made available as ROS topics, as standard ROS interfaces. Going back to the main menu, the next thing I wanted to show you is the speech capabilities of the robot. So if I click on speech, what we've been working on quite a lot over the last couple of months is speech capabilities of the robot. So the first thing to notice at the very bottom of the screen is this live captioning system. You can see what the robot is understanding right now, and you can also see what the robot says. So let's give it a go. Ari, what is your name?
I keep finding more new hobbies.
What is your name?
I am Ari, the robot.
Yeah, I'm not quite sure what he understood first, but the live captioning that you see here is actually really important for accessibility reasons. it's also, to be honest with you, a really convenient way of debugging what the robot can hear and not hear. Of course, here today, we are in a very quiet space. I'm not going to lie to you, and you probably already know that if we deploy the robot in the wild, sometimes the speech recognition is a bit more tricky to get right. One thing that is important though, everything takes place on board. So we are relying on open source, state-of-the-art open source tools to do the speech recognition, the voice synthesis, or the dialogue management. Everything is edge computing on the robot. So in terms of privacy, it's actually much better than, you know, like sending your participant data to the cloud. Talking about dialogue though, we are using a platform that you might have heard of called Raza. It's a very powerful dialogue management chatbot style platform that you can customize with your own behaviors, Python scripts, and it's quite easy actually to create new voice control behaviors. The platform is completely open, so if you want to, you can really easily create new verbal behavior for the robot. Going back to the main screen, we did mention expressiveness quite a few times, and that's one of the things that we've been also working on recently. I don't know if you really see on the camera; it's probably quite small. The eyes of the robot. I'm going to try to bring it closer to that other camera here. Maybe that will make it easier to see a little bit what we're talking about. So ARI has now fully procedural eyes. So you can create your own eyes. You can animate them. ARI comes with already a set of expressions. So if I, for instance, click on that one, can you guess what it is? Yeah, it's a sad eye. If I click on that one. Yeah, with the reflection of the webcam, it's not completely clear, but it was a scared robot. What we can also do, and we're going to go back to that main camera, is to write, and we support a standard called SSML, so speech synthesis markup language. We can write the text that the robot should say and annotate it with additional behaviors, like if you want to say something and change the eye behavior, the eye design, or add some gesture, you can easily do that. So I don't know, I take one example here. Or can we turn off the sound a little bit so that we can hear what the robot says?
Are you sure about that?
So the robot, yeah, we don't really see on the webcam. The robot is putting like uncertain eyes, creating a little gesture, or another example.
Full of energy today.
Full of energy today with happy eyes. That's something you can quite easily use in your own applications. Brilliant. Let's go back to the main menu. Yeah. So navigation is the next one. Unfortunately, we don't really have the space in this room to properly show you a navigation. What is quite important to mention, though, is that ARI, like all of PAL Robotics robots, is a ROS-based robot, which means that all the standard ROS tools for navigation, the move-based package, the 2D navigation package are available and works on ARI. Luca already mentioned the fact that you can add a LiDAR at the back of the robot, and you might wonder why at the back of the robot. Well, it's not by chance. The robot is designed, ARI has been conceived to be used in social settings, which means that we typically expect a lot of people to be in front of the robot, to be standing in front of the robot. And if you put a LiDAR in front of the robot with a lot of legs around, then it doesn't really work well. There's a lot of fake obstacles detected. So instead, what we do, we have the LiDAR at the back that is used by the robot for localization and provide really robust localization. And in the front, we use the RGB camera that Luca already mentioned that is hidden behind the screen that still makes it possible to do like local obstacle avoidance. So that provides ARI with this capability of quite powerful capability of crowd navigation, navigation in human environment. And what you can maybe see on the screen as well here in the top right corner is this interface. On top of the standard ROS tool, we also offer an easy-to-use interface to create, for instance, points of interest, region of interest on the map that you can then use in your application to tell the robot, oh, if you get into that zone, do that. Or if you get close to that point, then do that. The way it works is actually just connected to the next thing I wanted to tell you about, is the semantic knowledge base. So when you create a point of interest or a region of interest, it is stored into the knowledge base of the robot. And going back to the main menu and now clicking on reasoning and knowledge here. So what you should see here, it's a very simple knowledge base. We've just started from scratch for today's demonstration, but you can have as much knowledge as you want. It's a set of concepts that are connected together and that can be reasoned about. So what you probably cannot really read on the screen right now, but that's the list of the people that the robot already knows. So for instance, the ID 1, 2, 3, 4 is Raquel. The ID 5, 6, 7, 9 is Luca. If you create a new point of interest on the map, then it will appear there as well. And then you start enabling reasoning capabilities where you can say, oh, if you're in that room, then you're probably as well in that building. Or if you're close to Raquel, then you're close to the person that can speak, for instance. This kind of reasoning is made possible and comes out of the box. It's also quite important to mention that the knowledge base is already integrated with the dialogue, the chatbot system, so you can transparently use the knowledge base in your when you create verbal interactions with the robot. All right, and the last thing I wanted to quickly demonstrate is the motions. As I told you, Raquel will show you a bit more about that, but of course, ARI is a robot, it has arms, has in total 10 degrees of freedom plus the motion of the base, so 12 degrees of freedom. You can use all that. If I click here on one of the button, the robot will do, in this case, show left motion. The robot comes with a set of pre-programmed gestures, motions. You can easily create your own. And I know it's very tempted to click on play demo here, but I'm not going to do that because Raquel will show you in a minute how to actually build your own demos if you want to. All right. So that was a quick overview of some of the capabilities of the robot. There's a couple of additional things I would like to mention. I already said that the robot is completely ROS-based. I think it's important to insist a little bit on that. It's not just ROS-based, it's also the first robot that completely implements the new ROS standard for HRI, the ROS for HRI standards, that's also known as the REP 155, that standardize how humans and how their features can be represented and exported in a ROS system. Which means that if you get ARI today, you will have a robot that can be integrated with any ROS compatible, REP 155 compatible node module that will do some kind of human-robot interaction processing. Another thing that is really important for us, as Luca mentioned, with Raquel, our background is in research. We've been bringing a lot of robots to the field, to participants, and we also know how important it is to be careful with all the ethics and privacy related questions. I already mentioned the fact that most of our, not most, all of our processing takes place on board. So the data of the participants will never leave the robot. The face recognition, yes, it's on the robot. The speech recognition, on the robot. Gesture recognition, on the robot. Not only that, but because we implement the ROS standard, we also separate clearly in the system, for instance, facial IDs from the names. So things are not connected, they are in different databases. What we also provide is a one-click button to delete all the personal data that might be stored on the robot. So you run your experiment, you get your data, you click a button, you know that your robot does not contain any private data anymore. I'm not going to pretend that it makes the robot magically GDPR compliant. GDPR is a complex thing, but at least it should really properly facilitate your data management plan, for instance, to make sure that the robot is safe to use with your participants. But last thing I would like to mention, this robot has been designed, I would say co-designed by researchers in the frame of quite a few research projects. Currently, the robot is actually actively used in about 10 projects, big European projects like the Spring project, H2020 project, like the Shapes project, and also local smaller projects. like a quick video, for instance, of ARI being used in the Shaped project, where we bring the robots to older people homes. So we've been deploying the robot there. When I said the robot has been co-designed by a researcher, what I mean is that the version of ARI you see today with the new degrees of freedom, with all those new software capabilities, is also the result of what our colleagues told us in their experiments, what they were missing. For instance, a lot of the human perception capabilities come from the Spring project, where we also want to bring that ARI robot in an hospital. So that platform is a platform you can rely on, you can trust to actually run real-world experiments. Not only because it's actually already used in research projects, but also, and that's what I wrote at the bottom of this slide, is it's also a platform that we sell to, let's say, normal customers, businesses. So it's not only kind of a toy platform for research, it's also a platform that has a real-world usefulness. So if you develop your work and create new capabilities on that robot, the pathway to impact of your research will be kind of obvious because it's a robot that can already be used in the field. All right, I'm going to stop here and maybe hand over to my colleague Raquel, that will tell you more about how we can use that platform for education as well.
Okay, well, wonderful. Thank you very much, Séverin, for that wonderful talk. I think we have seen a bit of an overview of all the developments we've been working on with ARI. And it's great for research, as we mentioned, and also for businesses as well. But now let's have a look also to a third component, which is teaching. So as academics, we know that that's one of our duties, and we have to also focus on that and how we can transfer all this knowledge to our new generation of future roboticists, researchers, or whatever they're going to be. And that's what I'm going to talk a little bit now. So as academics, we all know that teaching is not just about lecturing, right? So we also want to have this experience, hands-on experience for our students, so they can really touch and then really put into practice all that knowledge they have learned, so they can really consolidate on that. But moreover, we also want them to experience with real robots and not just in theoretical environments. So ARI is going to be the right platform for that, and I'm going to show you a bit how we can do this as well. So whether you're you're teaching in areas of perception, for instance, or dialogue management, or affective computing, or verbal and nonverbal behavior, social behaviors for robots, or even like navigation, learning, decision-making, etc. Any of these areas that we typically work in robotics, you can do all that and go deep into those concepts with ARI. Additionally, at least for my experience, also I've been teaching for 4 years already with robotics students, and what I really try to tell them is that robotics it has a special different feature compared to other disciplines. Maybe it's a really complex subject where you have to learn a lot of different things, and most importantly, what we often don't do much is like integrating everything and putting it all together, so the system as a whole, right, like a full robot is really working and is really functional, right? Sometimes we just focus on some subparts of some sub-modules or some capabilities specific for that robot, but it's also interesting to put it all together. And that's what actually ARI allows us to do as well. So it's very important also to have a platform that we can go through these project-based activities where actually students can go through the whole development process. So it's starting really from like end user needs, understanding what the problem is, how can actually tackle that problem, then specifying the requirements and going through design, development, and then going also through the quick prototyping, testing and experimenting. I think it's really powerful for them to really see the whole cycle and see that they can actually do it, and in a very friendly way as well. It's not like it is complex indeed, but if we put the right tools, then we can make their lives much more easier and actually have these multidisciplinary projects that are really valuable now in our days. So that's not it, of course. Another thing that you can, of course, that students can learn with our robot is ROS, of course, as Séverin already mentioned, is 100% ROS based, and that means that, of course, you can go from very basic concepts to very advanced programming with ROS. So you can go, students can actually play with with the ROS framework at different levels if they want to. Okay, so the question is, so how do we do that, right? And of course, typically programming robots, we need, and in ROS especially, you can program in Python, you can program in C++, but we also need like additional tools right off very often, because sometimes it's like, oh, that's very complex, and like, how else can I help with this programming to build those behaviors for the robot that I want? And that's what I'm going to show you a little bit today. So we don't have a lot of time to go through all the tools that we have developed here at PAL. But let's go and have a look. How can we actually help with this programming? So what I'm going to do now, I'm going to share my screen, so you can see what I'm talking about, what I'm saying when I'm referring to these tools that we can use. So this is a web-based interface that we have developed so that you can have easy access to the robot status and all the different tools that we have here. So a very basic one, the information panel, is kind of general view of what the robot is doing in terms of its status, like it's docked, it has the battery, etc. And you can also control the volume, for instance, if it's connected, etc. So very basic things. But now let's move into the more interesting bits. So how can we have enhance the behaviors of our robots? So one thing that Séverin also already mentioned, and it's really important, as we know, for social robots, is to be able to move and to be expressive in terms of motion, in terms of its body, right? So let's have a look. So we have the motion builder over here. So basically, if I go into the motion builder, here's where I can create those motions that they can be very simple or very complex. So for instance, here we can see an overview of some of the motions that we have been creating so far. And let's try to create a new one, for instance. So if we just go into create new motion, then you can see here we have the main body parts, so the arms and the head. Basically, those are the main joints that we can control through this interface. So for instance, here I'm just pressing on this arm, and then I can just move. So if we can see the robot now, while I'm just moving this value on the joint shoulder, then you can see how the robot goes up and down. So then I can say, so I want this joint to be here, this other joint to be a bit more open, maybe just to turn. And then I can say, okay, fine, I'm happy with this. And then I also want to move the head. So we can probably just drag here to the right. And then I can see that the robot head is moving. And then I can just say, just capture. So capture this moment, basically. And that's how we work, how we build. So now I'm going to say, okay, now I want the head of the ARI to turn to the other way around. So I just move it to the other side. I say again, capture it. And as you can see here in the timeline below, then you can see how those, how we have already 2 keyframes. And then if we just play them, we can see the robot reproducing the whole motion. So if we go back to the other view, so you can see how it just moved. So that's one example of how to create this motion. So I'm not going to save it now, it was just to show you, but basically you have to name it, etc., so you can then access it again. So that's in terms of motion. So as I said, you can make them as complex, as simple as you want. And then you can easily use these motions through your Python script, for instance, or through other tools that I'm going to show you now. So if you go back again to the main menu here, you also have the access here. But let's go, for instance, to see a little bit about how can do the touch screen. So touch screen is another of the modalities that we often use when we're interacting with ARI, as we know, since we have to also overcome some other speech recognition process problems that we often have. So the screen is also a way of communicating and interacting with our users. So here's a very quick view of how we can create, for instance, a new page. So what will be appearing in the screen if you want. So you just give it a name, whatever it is, then you choose, you can choose from templates or create your own screen as you want. So let's make just a page with buttons, for instance, just to show something. And here you can see that you can have 3 buttons easily. You can change the background. So like, for instance, I can import an image, and then that will be what's being shown here. So I just can, for instance, I can open this, and then I said, okay, this is the page I want in the back. So it doesn't look very nice now. So let's just make it black, for instance, and that's it. And then we just remove that. So we have a black background now. We have the buttons here that we can, of course, customize that as well. We have round or different shapes, and then here you can easily just change the whatever you want to say. So imagine you want the robot to ask a question and you need the input from the person, yes, no, for instance, then you can just say yes. And then that will be it. And then you can have also say, okay, what do I want it to say? Well, when the user presses yes, for instance, I want the ARI to say sure, or something like that, right? And then you can easily just create these screens for the robot to interact with the user later on. So that's in terms of what the screen we can do with this, so the tool for developing the screens. And then I also wanted to show you very quickly that presentations. So basically presentations, what allow us to do is to create like, let's go into this one because it's a bit more complex. I already made this for the demo today. So basically what this allows you to do like scripted behaviors that are closed behaviors. And then you can combine the different modalities as we can see here. So you can combine speech, you can motion, the touch screen, so what appears in the screen, also modify the LEDs, for instance, the ear LEDs that it has, and even include slides, like things that you want to show in the screen at the same time. And as you can see here, we can just build those boxes when you want to start, what comes after, etc. And then you can make this composition of the different modalities, and then you can just play. So that, for instance, here, this was the demo I prepared. So let's say that I just want to modify this and to add like a thank you. And so just edit, so you can see how it's been updated now this, and then I can just play this presentation, which is the motion that Séverin was tempted to press before. So let's say we press it now, and then we can actually see, so it's preparing that. I was actually forgot to increase the volume. So actually ARI is what's talking now, but basically she's just demonstrating that she can refer her head, her arms, etc., and also the ear LEDs are also flashing in different colors, and so on. So that's just a very brief view on how you can create these scripted behaviors if you want to do. And finally, which also I find very interesting and very useful for students, especially when we're doing wizard the box experiments. So often we just want to have very quick behaviors done, and then just to trigger them as the robot is interacting with the user, and just to do our studies in that very easy way. So here the command desk is what allows us to do that. So you can easily see how you can create your buttons so easily. When the person says something, you can have ARI responding. So I'm just going to increase the volume so we can hear her talking. And then we'll go back to the command desk. So if I say yes.
Yes, no problem.
Yes, no problem. So you can also edit that. So as you can see here, I can edit any of these buttons. You can characterize them as you want. So I just characterize it for this demo. I just split into speech, motion, and the presentation, for instance. So I can just trigger any of those behaviors that I've created previously to show them. So and then you can change the name or whatever you want. So for instance, here we have all the motions again. So if you want to go here, you can easily see how you can just following the instructions, basically first step, second step, what's the name, what are you going to do, and what type of action you want the robot to perform. And then you can choose from all the motions you have prepared before, for instance. And yeah, and then just by pressing, then you can have the robot doing whatever you said. So I want to say like a nod, for instance. Yes, now it's nodding. And this is the motion demo that we just saw before the presentation that I showed you. Okay, so that's very quickly, I know, but as you can see, we do have some tools that really help us developing those behaviors for the robot that maybe sometimes can be very scary at the beginning, especially for students where they have to start and they don't really know how to start. So let's make things easy. And again, as I said, you can go very complex as much as you want. Based on ROS, you can connect any component you want, any model you want. You don't have to develop everything yourself. You can use what the community is also developing and integrate them everything in ARI and have a full robot working and being actually useful for our students to learn and to develop robots that are actually useful in our society. So that will be all from my side.
Thank you.
Awesome. Thank you very much, Raquel. And thank you, Séverin, for this really great presentation. And I hope that to our audience, it gave a better understanding of what ARI is and what ARI can do. So as we reach the end of the webinar, we're going to use these last minutes to go over the questions that you've sent us in the chat. Very well. So we get the first question, which is if ARI can recognize human emotions. What do you think, Séverin?
I think no one can really recognize human emotions, but to give a more useful answer, no, not out of the box. There is no box that will automatically give you the emotion of someone. However, what we currently do is to extract facial features, and there is lots, like tons of raw nodes that can turn that into an estimated emotions. I've seen quite a lot of projects, and sometimes you see those kind of videos where you have like the face of someone with happy, sad, disgust. I think anyone working in the field of emotion knows that those 6 Ekman emotions are not extremely useful. So we decided not to provide that by default. I think it's better to come up with your own trained model to recognize a specific set of emotional states that are relevant to your experiment. It's still something we are investigating. And actually, if in the community amongst you, some people can or want to point out a specific tool that they think should really be useful to a broad range of people and provide some information about the internal state of users, emotional state of users, then that's definitely something we would consider adding by default on the robot.
Okay. Thank you. Then let's move on to the next question. So how does ARI manage getting verbal commands from more than one user at the same time? How does ARI manage contradictory commands?
So that's another good and tricky question, of course. Anyone trying to do multi-party interaction knows that it's hard with a big H. It's interesting because I did mention briefly the Spring projects, and maybe some of our colleagues are here today. One of the big aim of the Spring project is to try to crack that nut. We are working with colleagues from the University of Heriot-Watt in Scotland that are experts in multi-party dialogue management. Their work is not yet on the robot. It's still, the project is going on. It will finish next year. But we are working in close partnership with them, and we certainly hope to be able to implement and integrate on the robot some of their capabilities. So to answer your question directly, today the robot is going to struggle if there's more than one person speaking. We have the groundwork in place to represent and deal with more than one speaker, but the speech recognition itself will struggle with more than one person. We hope to make significant progress on that question in the next 2 years based on the result of that research project with the colleagues from Scotland.
Brilliant. Thank you, Séverin. Let's address another question. So how much weight can the arm carry? And also, can fingers move individually or together? And can it serve as a gripper? Furthermore, can it bend its waist? I don't know, Raquel, if you want.
Yeah, sure. No, so ARI is meant for social interactions. It's not meant for manipulating the environment. So the arms and the hands themselves, as you can see here, they cannot really grasp any object, and they are just to convey and to be aligned with the user, so they can see a humanoid shape that is easier to connect with. So it's more about the design, external design of the robot itself. It's not about the capability of really grasping those. If you're interested in grasping, of course, we also have our Tiago robot, but then that would be another platform that you could use.
Yeah. Is it running on ROS 2?
That's already another good question. I'm going to take that one because that has been an ongoing discussion here. The short answer is no. Today, ARI runs entirely on ROS 1. However, as you probably know, ROS 1 is end of life in 2-3 years. I think it should be 2025. So as a company, we are now moving everything toward ROS 2. All the lower layer, let's say navigation, things like that, already works on ROS 2 at a prototype stage. It's not something we deliver on our robots, but it works internally. Our hope is that we will have a fully ROS2 compatible robot in the worst case in the next 2 years, because we have to. So that's definitely very high on our priority list. It's not yet the case for ARI, but that's something we're working on. If you have specific needs for ROS2, or if you're constrained to use ROS2, please get in touch with us, because that's also something that would be very interesting for us to know. Basically, if we know that there is a clear need by some of our users for something like ROS2, then we can also kind of make it faster, like get faster to that point. So please come back to us about that. It's important for us to know.
Brilliant, thank you. Let's see the next question. Can I get an SDK to develop apps for ARI? Can the SDK handle speech input and output without a real robot? And which speech tools are included?
So that's basically about our development on RASA and the dialogue management. So yeah, you can run it. Actually, when we do our first tests, we always do it in our personal computers, and you can input and output through the keyboard. And so you can do that in simulation perfectly well. So you can test all the dialogue process going on. So that's available indeed.
Yeah, and the broader question of, is there an SDK for ARI? The answer is we don't need one, in the sense of it's a ROS robot. So the SDK is ROS, which is super well documented, tons of examples online. We have, of course, simulation support. So you can run ARI in Gazebo, the standard simulator for ROS. So that makes it possible, for instance, to test the behaviors, test everything essentially without the physical robot. And as Raquel just mentioned, that also includes the speech processing, because the speech processing is not tied to the hardware. If you want to have a realistic simulation of the speech behavior of the robot, it's probably useful to have a microphone, just a similar microphone on your desk. They are RE-speaker microphone arrays, so you can actually buy them independently from the robot and then have the real same hardware. But yes, the SDK is ROS, and all the tooling and support that comes with it.
Thank you. Let's see what comes next. How do you design and manage dialogues between ARI and humans? Maybe for you, Raquel.
Yeah,
And that's a question for the audience. Huh?
exactly. That's can also work on that. So as already Séverin mentioned, also we're using RASA for that. So we've tried different approaches in the past as well. For now, we think that RASA is the right option for now, especially because we want to have these running everything on board the robot and not going to have to the cloud like other managed process systems would require. So that's what we're using. So it's not that we're developing our own system, is we're reusing external ones. So in this case, we're using RASA. So if you have any other system that can be that's already working very nicely, again, just let us know, because we'll be happy to just to test them and just to see how far we can get.
Yeah, before we were using these onboard tools, RASA and VOS, we were relying on Google solutions. So Google speech recognition and Dialogflow. Maybe some of you have some experience with Dialogflow. It's very easy for us to use them. Like, we have all the bridging in place to use those tools. So if you are already using tools like that, you would be able quite easily to use them with ARI. We've decided to try to get rid of it, at least to get rid of it in the default configuration, because basically we have open source alternatives that are as good as the Google tools, and they provide all the privacy features that we were looking for, something that can run on board, and also importantly, something that does not rely on having an active internet connection. So many times an experiment that works in the lab does not work in the field because of stupid internet connection issues. So ARI can run without internet connection at all if you want to. The last thing I want to add about how we design dialogues for humans. One of the reasons that we are really happy with RASA is this integration with the knowledge base that I quickly mentioned before. We think that as a research community, the next step to have more engaging, more advanced interaction between the robot and the human will require the robot to be able to make use of all the sensing perception capabilities it has, not only of the space around, but also about the people. And it's generally speaking quite hard to integrate dialogue with the perception. There is no magic tool to do that. And we think that the current approach that we offer with ARI, where we use an existing well-documented standard tool for dialogue management, but we provide the integration with the knowledge base of the robot that itself is fed with all the perception of the robot, opens a really pretty broad range of possibilities to develop advanced and reactive and like to develop the awareness, the social awareness of the robot. So that's the kind of tool that we really want to support today.
Perfect, thank you very much. Let's do another question. So in this education interface, can you make changes to the perception functions of the robot? So for example, replace the default emotion recognition model with a custom model, which is implemented in Python.
Yeah, absolutely. I mean, that's why it's one of the nice things of having ROS behind it. But basically, you can just replace your model for whatever you want, as long as the interfaces are the same. Like you just have to indicate how you're communicating your different models within your system. That's fine. You can use this the one you develop yourself, or you want to test somebody your colleague has done before. So you just replace that, and then the system as a whole will just continue working. So yeah, actually that's what one of the nice advantages. So when I was teaching also, it was nice to propose projects to the students where actually each of them will develop their own individual model, and then we can just test them and see which one performs better. And then when we go to integration, we just take the best one from each, and then we have our full system working. So actually that's one of the nice things to have.
Yeah, and in addition to that, something that Raquel already mentioned, all the interface that Raquel was demonstrating is web-based and runs on the robots, which means that for students, they don't have to install anything on their computer. They just need a browser, a web browser, and they connect to the robot and they have access to the interface. It also means that for you as an educator, it's just a web page. That's what you see. We don't provide out-of-the-box tools to create a new bit of interface, but at the end of the day, if that's something that you need, it would be pretty easy for us to tell you how to add your own bits of interface to do additional things, because it's not any kind of big software that you need to compile that relies on closed source bits. No, it's just a web page that has all these nice little widget, interface widget, but that's it. Well, plenty of questions.
Yeah, a lot of interest. How long can its battery last fully charged? For example, in a behavior where it patrols an area and interacts with people from time to time.
So with a question like that, I think it's time to check the battery of the robot to see if you're not dying. No, it's a joke. Raquel, you want to answer? Or?
Yeah, I mean, again, it really, as you know, it really depends on how active the robot is. Of course, if it's just here, like very static, just moving the arms and the head, then that doesn't consume so much battery, opposed to the scenarios you were proposing, where it's actually moving around, navigating in the environment. So that's really what drives the battery the most when you're navigating with it. So in that situation, then maybe it will last like a few hours. If it's more like in a static environment, it can last up to the full day. So then you can just recharge it through it, and that's what we expect. Usually when we put a robot in real world scenarios, so maybe they'll be interacting throughout the day, and then at night they can just fully charge again, so they are ready for the next day to work again.
And as you might have seen, or I think Luca mentioned it, we also offer automatic docking. So if you have a patrolling scenario, the robot can just go by itself to the docking station. And if you need to have like a continuous monitoring of a zone, then you probably need two robots, but they can kind of take turns and do that autonomously.
All right, shall we do another question? How does ARI support social navigation? For example, moving between people.
Yeah, so there is no dedicated social navigation capabilities on the robot beyond what you would get from ROS. So that means that, for instance, in a scenario where the robot is deployed in a crowd, a dense enough crowd, the robot would likely not move because it will see obstacles everywhere. So we haven't implemented on this robot out of the box a crowd navigation or like a dense social navigation algorithm. we are working on a daily basis with colleagues from tens of universities that are working on those questions. So we know that there is a lot of solutions, open source ROS nodes that do that, but that's not something that comes out of the box. The only thing that we do in terms of social navigation is, as we've explained, making sure that in terms of sensing capabilities, we are in the most favorable position. So having the LiDAR in the back and having an RGB-D camera in the front that gives us a pretty accurate model of where the obstacles are just around the robot, much better than what you would get with a LiDAR in front of a single LiDAR in front of the robot.
Perfect. Let's see another one. So I think you said that ARI uses the RASA conversational AI. I'm glad that some other people are also using it with their robots. I would like to try my RASA application on ARI. How can I do that?
Now you just give a ring to Luca and you buy your robot. Well, yes, we can do that. As you know, RASA is open source. You install it, you have your own application already. That's great. If you want to test it with the robot, I guess the easiest way is to run Gazebo with ARI in it, and then you will have all the ROS topics. But to be honest with you, there will be a bit of legwork to bridge your own RASA application with all the ROS topics that are exported by the robot. It's not something that will kind of magically work. Yes, all that work has been done on the robot. If you want to start using RASA outside of the robot, your own application, and try to make it work with the robot, that's not something that we have properly documented yet. I would say there's no simple tutorial that I can give you that will show you how to do that. But that's a good idea, something we should do.
All right, as we're running out of time, this is going to be the last question. So can ARI learn things like preferences or human behavior over time?
I think that's part of the knowledge that we're trying to convey to you. So it's basically whatever you want to develop, and those capabilities are like high-level capabilities. Let's say if you want to have them, you can of course develop them. We don't provide them at the moment, but we're starting with this knowledge-based reasoning that we have. So actually, we're working like on time-stamping some of these information. So we could actually go like through a history of events that have happened and that the robot has perceived, has gone through. So then you can start reasoning on top of that. But at the moment, so we don't directly address that, but it's something that, of course, you can easily do on top of it. And I hope with the tools that we're developing now, can be even easier to do that in the short term, actually.
All right, awesome. So a big thank you to our participants for staying with us for the past hour. So in case we didn't have time to address your question, no worries. We'll get in touch with you individually via email. And of course, we're going to send the materials that we used today. So the entire presentation will be sent to everybody who was participating in the event. So thank you very much. I hope you enjoyed the content, and I hope that you like our ARI. So yeah.
Thank you.
Thank you.
Thank you very much.
Bye-bye.